Alright, so it's asking us to find values of C, values of A and C as the piecewise function differentiable. So we need two things. To be differentiable, we have to be continuous on the interval, and then we also have to be able to take a derivative. So basically, when you have two variables to solve for, you need two sets of equations. So, because you've just set up a system. So the first thing I would do is probably take the derivative and set them equal to each other. Okay, plugging the pi in for the x. Okay, and then I'd probably also set them equal to each other with the pi in it. So let's try that. Let's start by taking our derivative. So remember, a and c are going to act like constants. Okay, so where's that squared going to go? In the front. So it'd be 2ax. What's the derivative of sine? Positive cosine. You guys need to make sure you memorize all your trig derivatives this weekend. So Sunday after homecoming, memorize your trig derivatives. Okay? And then what's the derivative of 2x? 2. And what's the derivative of c? It's acting like a constant? No. 0. It's acting like a constant, right? It's acting like a number, so it's 0. All right, what am I supposed to plug in there? Pi. So I've got 2a times pi plus cosine of pi equals 2. All right, cosine of pi would be over here, right? What's the cosine of pi? Negative 1. So I've got 2 pi a minus 1 equals 2. What am I going to do to move the 1? Add it to both sides, so we end up with 3. And then what are we going to do with the pi over 2, or the 2 pi? Divide it. Look at your answer choices. Are we on the right track? Yeah, we're on the right track. In fact, look at all the answers. It's all the A's are the same, aren't they? I better have gotten that for A. I almost didn't need to solve for A, right? Because they told us the A value. All right, I just needed to find C. So to get C, I take the originals and I set them equal to each other and plug the pi in. So I'm going to do A times pi squared plus sine of pi equals 2 pi minus c. What could I put in for the A, actually? Can't I sub in for that, too? 3 over 2 pi. So 3 over 2 pi. Okay, let's see if we can get that simplified. So doesn't this pi cancel with one of these? Yeah, so I really have 3 pi over 2. What is the sine of pi? 0. So that goes away, equals 2 pi minus c. Instead of 2 pi, I'd probably write 4 pi over 2, right? That's really bad. I shouldn't write it like that, because now it makes my pi look like it's in the denominator. Should be 4 pi over 2 instead of 2. Okay. Why did I cancel it? Because this pi was in the denominator, and I took away one of those, so it's still got an exponent of 1, right? All right, when I move this over to the other side, what do I get? 3 minus 4. So negative pi over 2 equals negative c. But what's going to happen with the negatives? Cancel. So we're going to end up, it looks like, with this fourth answer choice here. That one, you guys, I pretty much guarantee you're going to see either that one or the continuous one. One of the two usually appears on the multiple choice AP. Okay? That's why I keep picking on it and putting it on stuff. All right, what other numbers do you guys want to see? I will do whatever you want, because Monday we got to do hints. Right? So whatever you guys want to see, let me know now. Why I did 4 pi over 2? Because I needed a common denominator. Oh, okay. Right? So I'm automatically just going to that common denominator instead of writing another whole line of work. Okay? Working smart, not hard. Okay? It is Friday. We want to work smart, right? Okay, what else do you guys want to see? 4? All right, so a particle moves along the x-axis so that its position in time is given by that function. For what values of t is the velocity of the particle 0? Okay, so velocity comes from where?
I know this. This is physics. Velocity.
Come on, come back. What derivative? First derivative. So I'm going to take, to get the velocity, I'm going to take the first derivative of the position. Okay? So, what is the first derivative? What's the derivative of t squared?
2t.
2t, and the derivative of negative 7t? And the derivative of 6? 0, which I'm not going to write down. For what values of t is the velocity of the particle 0? What do I have to do now? Set it equal to 0. There's only two choices. Either I'm going to plug something in or I'm going to set it equal, right? This is a set it equal scenario. All right, so I'm going to move the 7. So 2t equals 7. T equals 7 over 2. So what's the answer got to be? 3.5. And that probably would not be, you know how we have calculator and non-calculator? That would still probably be a non-calculator problem, even though it's got decimal points there. Okay? All right, what else? Make sure you're picking on the harder ones. Nothing? Seven, sure. All right. It gives us f of 5 is 6, f prime of 5 is 7, then the equation of the tangent to the curve. So what two things do we need to write an equation of a tangent line? Slope and point. The slope comes from the derivative, so there's your slope. The point is right here, right? Remember, we have to get used to the fact that a point in calculus is not written like that. Typically, it's written like this, in that format, okay? So there's no figuring out my parts. I just have to plug it into the formula. So y minus, what's your y value? 6. What's your slope? 7 times x minus, what's your x value? 5. Now, free response, we'd leave it. This is a multiple choice question, so I need to keep going, right? So what do we need to do with that 7? Distribute, so 7x minus 35, and then what do we need to do with the 6? Add it. And look at this. It's either got to be 35 or 29. Which one is it going to be? Better be the 29, right? All right, what else do we need to talk about? Which one? $25. All right, so what rule am I going to need? I've got division. Quotient rule. So we got to do low d high, right? So f prime equals, so low is 3x squared minus x. The derivative of the high. So what's the derivative of 3x squared? Good. And the derivative of x is 1. Minus low d high minus high, 3x squared plus x, derivative low. So we get what? Minus 1 all over the low squared. 3x squared minus x squared. That was nice of him, wasn't it? Okay, so we've got to figure out what we've got here. Probably what I'm going to do, even though it's not pretty, is I'm going to go ahead. I have to simplify to one of those because it's multiple choice, right? And none of the denominators are giving it away right now, unless I've got a typo in there somewhere. So let's see if we FOIL this and see if we can get to one of the numerators. So 3x squared times 6x is 18x cubed. 3x squared times 1 would be 3x squared. X times negative x times 6x is negative 6x squared. And negative x times 1 is negative x. I'm going to do something to help us out on this next part here. I'm going to take that negative and distribute it over one of them. You don't need to distribute over both, just one. Okay, so now I can FOIL this back part without having to mess with that negative. So 3x squared times, negative 3x squared times 6x is x cubed. Okay, 3x squared, negative 3x squared times negative 1 is? Good. 3x negative, no, so we did that. Negative x times negative 1 is? Positive x. I did the last instead of the middle, didn't I? Sorry. Negative x times 6x is? Good. Okay, so let's see what we can do with combining like terms. Our denominator is still the same, right? Let's not mess with that yet. All right, so the 18s go. All right, let's see. I've got 3x squared, and 3x squared is... Doesn't one of the 6x squareds go then? Okay, so that's gone. I'm left with a negative 6x squared. And then here we've got... Oh, what happens with the x's? They cancel as well. Over 3x squared minus x squared. Interesting. What does it say the answer is? Yeah. I think I got them all. What does it say the answer choice is? If anybody click on it and... We could take out an x, that's true, but I haven't foiled that yet, so maybe I should foil that and see what happens. It's C, supposedly? It looks more like C. If I took out an x, I might be able to get to that, so let's try that, okay? So if I foil this thing out, my guess is I foil and I'd have to factor again to get to that denominator. This one's ugly. I probably wouldn't put this on the test. What's 3x squared times 3x squared? 9x to the 4th. In the middle, let's see, 3x squared times negative x would be negative 3x cubed. And I'm going to have two of those, so negative 6x cubed. And then negative x times negative x is positive x squared. So do we see how we factor out an x squared? Okay, so let's take out that x squared. Good eyes on that one. We knew we had to get rid of it because that was the only numerator that made any sense, right? So 9x squared minus 6x plus 1. So those are gone. At this point, now that we've gotten that far, could we probably wager the guess that that is the same as this? Yeah, so it's got to be answer choice C. Okay. And remember, multiple choice, yes, you're going to show me some steps because I'm going to give you some points back for that. For showing your work, remember, I'm going to give you 5 points back. But do you have to show your work all the way once you know your answer? No. Okay. All right, what else? Number 10. Yeah, that one was ugly. I don't like that one so much. But it's good for us to look at them. Okay. AP loves stuff like this, where they give you the information in a chart. So, they're wanting us to find the slope of the tangent line. Okay, at the point x equals 2, notice they're all evaluated for 2. They don't give you an actual function. Okay? Slope comes from the what? Derivative. Okay? I have a division, so what rule do I need? Quotient rule. So I'm going to do the derivative of this with the quotient rule. So low d high minus high d low over the low squared. Now really, instead of x's, what should I probably plopped in there? 2's. So I could put the 2's in there if I really wanted to. We're probably not looking at your work, right? All right, so now all I'm going to do is I'm going to read what it says. It says g of 2 is 3. F prime of 2 is 5. Do you see where I'm getting my numbers from now? All right, f of 2 is what? Good. G prime of 2 is 7. All over what is g of 2 again? 3 squared. Okay, so 15 minus 70 over 9. What's 15 minus 70? So it's got to be d, right? Was it? Was there one like it? Something like it? Good. AP loves it, the setup like that. So that's part of it is, we don't have a lot of material to cover, but the way they present it is weird sometimes. So we got to hit all those, and that's by doing these multiple choice problems, we hit some of those nuances. All right, what else? What else do you guys want to see? Number 8. Okay, so we've got a chart again, right? This time, what rule are they wanting us to do? Product rule. Okay, so when it says h prime of 2, I'm going to go ahead and throw my 2's in there. Okay, while I'm doing this. So, it's keep the first, so f of 2, derivative of the second, g prime of 2. Plus, keep the second, which is g of 2, times the derivative of the first, f prime of 2. I only need this column of the chart, right? Yeah. What they probably did is the chart, I don't know if it was used for more than one problem. It might have been used for more than one problem out of a prep book or something somewhere. Okay? All right, so what is f of 2? 0. G prime of 2? 3. G of 2? Good. And f prime of 2? 5. This first term doesn't matter, right? So isn't the answer -5? Yeah. Actually, those problems, I like to see those problems. They're not that bad. I'm not dealing with a lot of algebra there. It's pure calculus. And plugging some numbers in. Right? So you be thankful when we see that kind of a problem. Even though it looks awful. Okay? Alright, what else? Which one? 24. Okay. Alright, so g prime of 4. Okay, so I've got to just take a straight derivative there. So g prime of x first. So what are we going to do with this 4? Move it to the front. So I've got 4 over 32, which I could reduce. I'll do that in a minute. X to the what power? Third. Subtract 1, right? And then take this and multiply it by the front. So what do you get there? Just x to the first, right? I could go ahead and reduce that. So what is it? 1 over what? 8. All right. And then now look back at the instructions. What do they want us to do? Plug a 4 into it. All right. So what is 4 cubed? Yes. Good. Some of us, I saw you looking at the walls. That's okay. 4 times 10. You know where to find the answer. That's part of it, right? Okay. 8 into 64, how many times? 8. 8 minus 40 is? Good. You guys, in calculus, we have to give you tests, right, when it's a class? In real life, when you're working, won't you be able to look up the answer if you don't know it? Yeah, so you guys, knowing where to look is half the battle, okay? All right, what else? 31. Maybe. Okay, particle's position is given by this function. Acceleration, what is acceleration at time t? What derivative is acceleration? Second derivative. So I've got to take the derivative of this twice. So s prime of t, or s prime equals what? 3t squared t plus 9. Good. S double prime, which is the acceleration. Okay. 6t, good, minus what? 12. What do I have to do? Plug in a 4. So S double prime of 4, or the acceleration at 4. Sometimes they put it in there. It depends on the publisher, because I basically took a whole bunch of prep books and typed up their problems. So, all right. So 6 times 4 is 24 minus 12 is 12. So it's E. Again, these are AP level, what you would see on the actual AP test. Okay, I can't show you free response yet, but I can show you multiple choice. All right, what else? Are there 29? All right, looks like now this one isn't simplified. Look at the answers, right? So kind of is almost nicer than that other one that we did. So we've got a good quotient rule going on. So we've got to do what first? Low D high. So x cubed plus 7, derivative high is going to be what? minus 1, good, minus, so high D low minus, I'm sorry, low D high minus high D low. So 5x to the 5th minus x plus 2. Derivative of low is what? 3x squared all over the low squared. All right, just looking at low squared, what are our only choices? D and E, right? We've got it down to just D and E. All right, so which one is correct? E, right? That has it in the right order. This one is backwards. They went the other way. That was basically just a strict application of the rule, right? All right, what else? That was it, yeah. 12. All right, average rate of change means, okay, so when you see these words, and notice there's an interval, you're going to find slope using y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's different than just taking the derivative and plugging in, because they gave us an interval. Okay, and they said average rate of change versus just rate of change. Okay, so what I really have to do is I have to find f of 3 minus f of 1 over 3 minus 1, because those are x values. That's a 1 in there. Okay, so I'm going to plug into this thing here. Let's see, 3 times 4 is what? 12 minus 9 is what? 3. Okay, we're plugging in a 1. 4 times 1 minus 1 is 3. The denominator's 2, right? So 0 over 2 is going to be what? 0. You plug into the old slope formula, right? That's all we did was take our y's and over our x's. And again, just like the old slope formula, it doesn't matter as long as the pairs are in the same order, right? You could have put your 1's first and your 3's second. That would have been okay. All right, what else? $13, sure. All right, so we have a function. The graph of the derivative of f is, okay, let's take the derivative. Okay, so if we're going to take the derivative of that of this here, what's the derivative of 3x? 3. What's the derivative of 2? Okay, so let's think about that picture. Remember, it's same as saying y equals 3. Is y equals what? Y equals is what kind of line? It's a horizontal line, so it's got to be answer choice A. If it doesn't make sense by looking at it, do the derivative, try drawing the picture, right? You can't be afraid of drawing that picture. Some of us really have to actually see it, right?
It's always if it's a whole number, it's just a horizontal.
Not if it's a whole number. If it's just a number, it's a horizontal. If it's y equals a number. If it ended up being x equals a number, that's the vertical, okay? If we had, think about the derivative dance. If we had started with the squared, wouldn't it have gone to a line with a positive or negative slope? We weren't there yet, right? We started with a line. In the derivative dance, a line goes to a horizontal, doesn't it? Okay? So yeah, you got to think. The derivative dance is awesome because it helps you picture it really easily. Okay? All right, what else? 14. I'll be watching you do it during the test, right? All right, you want this problem on the test. What's the derivative of a number? Aren't you glad we answered that question?
Yeah.
It's okay, it's Friday, right? 9? Okay. Sometimes they are, right? They look so simple, they're hard. All right, we got a good old quotient rule again, right? dy dx means just find the derivative, right? So just another notation for that. All right, so the quotient rule says we do what? Low D high. So 5 minus 2x, derivative of high is going to be what? 2. So this one isn't as bad as that one of those first ones we did. So low D high minus high, 2x plus 7, D low. What's D low? Negative 2. All over the low squared. And looking at all the denominators, I didn't even need to do the denominator, right? I need to mess with the numerator. So what are we going to do with this 2 right here? Good. So we get what?
Minus 4x.
Good. All right. I'm not just, what's this negative times this negative here going to do? That's going to go positive, right? So I'm going to just, so that way I'm not messing with that. I'm going to distribute in this 2. So what do you get when you distribute that 2 in? 14. What's going to happen with my 4x's? Cancel. So what's my numerator going to be? 24. So it better be this first one here. Why did I stop writing the denominator? They're all the same. If it was free response, I'd say, yeah, you need that denominator written. But multiple choice, we can sometimes take some shortcuts. Don't start bad habits, though, okay? All right, what else? Are there others that you guys want to talk about? Which one? 15? We don't need to do that one? Yeah, that's kind of like the other one, right? There was 0. This one's just 5. All right, what else? Which one? 20. See, we didn't need to do all of them. Some of them are really easy. All right, we've got a particle whose motion is represented by the position. Notice, sometimes the position function says s and sometimes it says x, right? So you got to kind of get used to both of those. S is in feet per second. They want us to go to acceleration after 2 seconds. So acceleration is what derivative? Second. So I'm going to go to the second derivative of this thing. What's the first derivative? 2t minus 1. Okay. And the second derivative is what? 2. I don't have any choice. I don't have anywhere to plug the 2 seconds into. No matter what I plug it, it's going to be 2. And they already did your label in feet per second squared.
Wait, what are they making it? They chose 2 as well, but they broke a wrong notation.
If
They
what?
do that to us? Like write the wrong notation? Have 2 options? What would correct notation be?
Not usually. Oh, you mean like having a feet per second squared?
Yeah.
Not usually. But, you know, it's something to always make sure you know, right? Good. Nobody's ever asked that before. So, all right, what else? Number 2? Sorry, I was kind of spacing it there, Lauren. All right, if the nth term of the derivative... Okay, somebody was asking me about this one yesterday. So what we need to do is do the what derivative? 7th. And eventually it's going to cycle back to one of these. Okay, so our original is negative sine x. Okay, y prime is going to be, what's the derivative of sine? Cosine, but we had a negative floating out in front, right? Okay, second derivative, what's the derivative of cosine? Negative sine, but that's going to end up going positive. Third derivative. Derivative of sine is cosine. Okay. What's the derivative? I'm going to go to the fourth derivative. What's the fourth derivative? Do you see how I just started repeating myself? And the reason that happens is, think about unit circle. Doesn't it? Can't it keep going and going and going and going? Or think about the graph of sine and cosine. It's periodic, right? It goes up and down and up and down. So it cycles. That's why trig does this. Or why this happens with trig. Okay, so fifth derivative would have been negative cosine. Sixth derivative would have been negative sine x. So positive sine x. So seventh derivative is cosine x. And it is the same as the third derivative. Okay. But now you know what you're looking for, right? Now you know how to do it. And that's not something that we would have seen in the book, right? They don't ask a question like that. That's why I'm doing the problems this way. Okay? What else? Are there any others you want to see? You've still got about 10 minutes. 26. Slide 26. All right, so we learned these derivatives the other day. You still got to memorize them, is my guess. Okay? So, what is the derivative of secant? Do we remember? Good. Secant x, tangent x. Good job. And then the derivative of cosecant, look at your answer choices, has to be what? It is negative. Cotangent x. All right, remember when you take the derivative of something that starts with a c, its derivative is always negative. That says cotangent. It doesn't look like it, but it does. I started writing the wrong thing. So cotangent x. Okay. Nothing else to it, right? It's a one-liner. All right, what else? 28. All right, what is the instantaneous rate of change? Instantaneous means take the derivative. Okay. What am I going to have to do for the derivative? I've got a division here. Quotient rule. So f prime of t equals low d high. So low derivative high is what? Plus 1. Minus the high. Sorry, the high, I circled the wrong thing with my pen. 3t plus t. Derivative of low is what? 4. All over the low squared. Now, this is one where I wouldn't try simplifying because we're just plugging a number into it. It's easier to simplify the numbers. Okay, so I'm just going to plug my number in. What is negative 1 times 4? Negative 4 plus 1 is? So I'm going to show every single little step. Negative 1 squared. 1 times 3 is? Plus 1 is? 4. All right, what's negative 1 cubed? Negative 1 minus 1 is what? Negative 2, and then we've got this times 4 all over. Let's see, 4 times negative 1 is? Negative 4 plus 1 is? Just 3, right? Or squared would be 9. Okay, negative 3 times 4 is? Negative 12. Let's see, double negative is going to go positive. 2 times 4 is? 8. Negative 12 and 8 is? Negative. I didn't need the 9 anymore, right? I didn't even need to do the denominator, did I? No, all we needed was the numerator. All right, what else? 27, absolutely. Okay, what is it? We did one like this, didn't we? Which one was it? It was the same one? I think it just must be on the worksheet twice. Oh, yeah, it's right there. It's the same as 24 for some reason. Or were there two 24s on here? Yeah, 27 and 24 are the same problem. You just got to cross one out. The homework assignment just got shorter. All right, what else? Number 6? Sure. All right, position of a particle moves along the axis. What is the speed? Okay, so speed is the what? It's the absolute value of velocity. So I need to go, how do I get velocity? First derivative, and then I plug my 4 in and take the absolute value of it. Okay? So x prime of t is the same as the velocity of t. So let's see, what's the derivative of 2? No. 0. Okay, derivative of 3t. 3. Derivative of negative t cubed. Good. What are we supposed to plug in? A 4. All right, so 3 minus 3 times 4 squared. What's 4 squared? 16 times 3 is? Good. 3 minus 48 is? Okay, look at the answers. If you stopped there, would you get it right? No, it's supposed to be the what? But they gave you that as a choice, right? So I need to take the absolute value of that. What's the actual speed? 45. Because remember, velocity takes direction into account, whereas speed is just how fast are you going in that direction. Okay? All right, what else? True. You could have crossed out the negatives to begin with because you don't have negative speed. Okay, because it's absolute value. All right, what else? Are there any others you want to talk about? 19? Remember, when I give the test, I pick a couple of these exact problems. So it's good to make sure you know these in addition to your hints. So consider a particle whose motion is represented by that position function. What is the velocity of the particle after 2 seconds? So to get to velocity, what do I need to do? First derivative. Okay, so what's the derivative of t squared? And the derivative of negative t? Good. And then what do I have to plug in? 2. So that's the same as saying velocity, right? So velocity at 2 is 2 times 2 minus 1, which is going to be what? 3. And notice they labeled it for you again. All right, what else? Are there any others that we haven't done yet that you guys want to see? 21. All right. What is the position of the particle at time t equals 2? Is there any calculus involved in this? What are you going to, if this is the position, what are you going to do with that number? Plug it in. So s of 2 equals 2 squared minus 2. So 2 squared is 4 minus 2 is 2. Position is not, doesn't have the per second, right? Position is a foot or a meters or something like that. All right, anything else you want to talk about? 23. All right, so I need to take this and put it where? To the front. So we've got 5 times 4/3 x. Now we're going to subtract 1. In this case, we're going to subtract 3 over 3, which is going to be what? 1/3. I guess I could simplify 20/3 x to the 1/3 power. What are we supposed to plug into that? 8. Now it's work smart and not hard, right? So instead of writing an 8 in there, what's a better name for 8? Why 2 cubed? Why am I picking on that? I can cancel this, right? So then I have 20 times 2 is what? 40 over 3. All right. Are there any others you want to talk about?
30.
Which one? 30. All right. Equation of a tangent line to this at x equals 3 is. All right. So equation of a tangent to that line at x equals 3. So equation of a tangent, we need the what? We need a point and the slope. I have an x value. To get the y value, what would I do? Plug in. So y of 3 would be 4 times 3 cubed minus 7 times 3 squared. What's 3 cubed? 27 times 4. You can use your calculator. 108, and then we've got 3 squared is 9 times 7 is, good, 108 minus 63 is, look at your answers. It's either got to be a 45, it's got to be a 45, doesn't it? Look what's in the y spot. You just have to decide if it's positive or negative. Okay, so I know that my y value is, my point is 345. To get the slope, what do we have to do? What do we have to do to this? What is the slope in calculus? The derivative. So we've got to take the derivative of that, right? So what do I do with the 3? Front. So 4 times 3 is 12x squared minus what? 14x. Good. And then what do you think I'm going to do with the 3 again? I got to plug it in again. So let's see. 3 squared is what? 9, and then minus 14 times 3. All right, put that in your calculator. I'm going to guess it's probably 66 because it's not 1 over 66, right? Look at all your slopes. Aren't they the same? Yeah. All right, so point slope would say y minus what? What's your y value? 45 equals my slope 66 times x minus 3. You could have narrowed it down based off of just the 3 and the 45. You could have gotten rid of that one and probably that one, right? And then you just had to find, you had to still find the slope though. All right. It's already 7:50. We've been having this fun for a long time. All right, so I'm gonna let you guys go. This weekend, probably on Sunday is my guess, because you've got homecoming Friday and Saturday. Hints. Okay, get those done. I will still take the cookie dough through Tuesday. We only had about 48 people turn it in, which is only about